Hey guys, welcome to Unit 6, Section 6, which is geometric mean and similar right triangles. So really quickly, this isn't going to be as important, but arithmetic mean and geometric mean, the way that you calculate arithmetic mean, remember mean is the average, it's the same way that you've done it in the past, where you just have, in this case we have two numbers, so we add 4 and 16 together, and then we divide by the total number of numbers, so 4 plus 16 is 20, and 20 divided by 2 is 10. So that would be the arithmetic mean. Then we have the geometric mean, which is where we multiply to give us 64, and then we actually take the square root of that number. So you multiply them, and you take the square root. So you end up getting 8. 8 is the arithmetic mean of those two. All right. Now, similar right triangles, we want to look at how the triangle ABC has been divided into two smaller right triangles. Basically, this is going to be the setup every time. You're going to have the exact same diagram. Notice we have a right angle here, a right angle here, and technically the one right next to it would be another right angle. So there's three right angles that are visible, and there's actually three triangles here. We have the big triangle, which is ABC. I'll just outline it here. This one. Then we have the medium-sized triangle. We do it in a different color. We'll do it in this one. This one here, which includes points A, C, and D. Now, A is going to correspond to A, as you'd probably guess. And then we go to the right angle, which is now D, and then C is going to be the, or excuse me, I went to the wrong one. Oh. So it's actually going to be C next. ACD is the right angle, which is the same thing as C. C was our right angle. And now the last one can be a little tricky. So it's going to be C, let me do this in a different color. C, because that's the highest point. D goes last, and then B, which is this small triangle right here. So there's three triangles, and the proportions that we set up vary depending on which triangle we're looking at, but they are all similar by angle. All right, so let's actually practice this. So complete the proportions below. The way that I want you to look at this is think about it like there's three different triangles. So WT is, we like to call these the long leg, short leg, and hypotenuse. So WT is going to be a long leg because it's a right triangle. There's three different sides. So we have WT is long leg. Ugh, I keep having to switch colors, I'm sorry. Long leg. And then ST, a part of that same triangle, it's the medium-sized triangle, is going to be the hypotenuse. So we need to find a long leg and a hypotenuse involving ST on a different triangle. Well, if you look at ST, it's a part of the big triangle and the medium-sized triangle. So for the big triangle, it is actually the long leg. So, which makes sense. So these are both long legs. We need to find the hypotenuse of ST of the big triangle, which is actually RT. Now if we do that same thing over here, we have RS. RS is compared with RW. RS is going to be the short leg of the big figure, and RW is also the short leg of the smallest triangle. And then ST, if we are comparing that, ST is the long leg, so we need another long leg on the small triangle. And the long leg for that one would be this WS. Basically, you're just trying to pair up short leg, long leg, or hypotenuse, and just make sure you can set up a proper proportion. I'm not going to go through the rest of this here. I'm going to actually get to some with some values. So let's set up a proportion. Let me just go to a different color in general. This will show it better. Now we are trying to solve for x. X is a part of the medium triangle and the small triangle. So if I want to use let's use the medium triangle. So I'm going to say x and 4. X is going to be the short leg of the medium triangle, and 4 is going to be the hypotenuse. So I need to find another relationship that involves short leg hypotenuse. And I know all the sides of the big triangle. I know that the short leg for the big triangle is this one here, 3. So that's going to be short leg, and then the hypotenuse is 5. And now I'm able to set up a nice little proportion. We get 5x equals 12, divide by 5, and we get x equals 2.4. Now we actually could have set up other ways for that one, but that's just one way to do it. Okay, we're going to try a couple more here, and then we're going to call it for this one because we're going to have a day 2 of this. Set up a proportion to solve each of the following. So this time, look for what y represents. Y is both the short leg of the big triangle and it is the hypotenuse of the small triangle. So what else do we know? We know another short leg. So we are going to set it up as y over 4 equals, so if we do y over 4, that's the hypotenuse. If we look at the small one, and 4 is the short leg. So now we want to look for another short leg hypotenuse relationship. If you look at the big triangle, we have 15 is the hypotenuse, and y is the short leg of the biggest triangle. This one's kind of interesting though. We do have to be careful because when you cross multiply, 4 times 15 is 60, and then y times y is y squared. So we actually have to take the square root of both sides to solve. And y ends up being, let me get my trusty calculator out here. So I want to find the square root of 60. I'm going to hit second, 60, and we get 7 points. We're just going to round to 7.7. So it's about 7.7. All right, let's go ahead and do the same thing over here. Find the value of z. So z is the hypotenuse of the big triangle. So we have to use that as the hypotenuse. And then the only other thing we know about the big triangle is the short leg, 27. So we're going to do hypotenuse over short leg, 27. Set that equal to, so we need another hypotenuse short leg, which if you look at the small triangle, we have the hypotenuse is 27 and the short leg is 16. So it ends up being 27 times 27 and z times 16. So we get 16z equals, I don't know what 27 times 27 is on the top of my head, 729. 729 divided by 16. I'm going to go back to this, divide by 16, and we get 45 we would round to 6. So z is approximately 45.6. Okay, so basically, just to recap, our goal with these is to set up a proportion that uses the same sides, just with different triangles. So whether that's hypotenuse, short leg, or long leg, that is our goal.